The dependent t-test examines the significant difference between two sets of related scores. So these are the paired samples. So for example, linked to gymnastics, this could be the mean range of flexibility in the hamstring and lower back in the sit and reach test for one group, and they are different. They are measured different pre and post training. So, like for example, pre and post P and F stretching, and the results are calculated using the formula. As you can see in the first picture, the formula is in the middle. This shows the difference between before and after, which is equivalent to D. The number of paired scores is N, and then the E thing is the sum of, so it might be the sum of the differences or the sum of the numbers. So to calculate it, to calculate your t-value using the formula, you calculate the degree of freedom, which is the df, for the dependent t-test using the formula n minus 1. So for this example, the df is n, which is the number of participants, which is 6, minus 1, which is 5. And then you compare your t-value on the table to the critical value. So you go along 0.05, as that's the p-value, and then you go along down 5 and you circle it along, and then that number, the crossover is the calculated t-value, or the critical value. So in this sample is 0.71. So this shows that if the t-value is 3.2, so 3.2 is greater than 2.5, is significantly different. So after calculating your t-value, you compare your results to the critical value and find your df. Then you go across to see the results in the greater, so 0.05. If your value achieved your t-test is equal to or greater to the number shown, your result is significant, and if df is more than 120, use the infinite column at the end of the table. So as you can see, the t-value is greater than the mean. So this means that you can say there's a significant difference between pre and post training. So within the dependent t-test, the participants is n, so that's calculated by the highest numbers, that's 6. Pre-jump training height is calculated by add them all together, same as post, so that gives you that weird E thing. Then the difference is the difference between pre and post, so that gives you that score, and then you square those answers. So the first picture shows how this is calculated, fitting it into the formula. This means that as you linking back to the tree, as you follow it round, is it different correlation or categorical is different, and then it has 1, so you follow it round, same or different participants use the sameness, so that means it's parametric, so that means that it's the dependent t, that's the wrong one. Round, it's inferential statistics, so then it's a parametric checks as you've used the same participants, and it's the t-test. For the independent t-test, it's the most frequently used t-test. It is used when you have two groups and trying to discover if the mean sources of the two groups can be considered to be significantly different. The dependent t-test is suitable when the data you've collected is interval ratio data. and the groups are randomly assigned and selected by random by the researcher, so it's not biased. And when the spread in the two groups is equal, the independent t-test is calculated using the formula. So for the t-test, is t equals m1 minus m2 over the square root of s 2 over n plus s2 2 over n2. So m1 is the value group of the mean value of group 1, m2 is the mean value of group 2, s1 is the standard deviation of group 1, s2 is the standard deviation of group 2, s1 is, so this, for example, this one's over 10, whereas the other one was, don't know, it was over 10. N1 is the number of participants in group 1, N2 is the number of participants in group 2. So it's over 10 because this is the number of participants within the group. So you would follow the round. So M1 is 2.866 and it'll test subject minus M2, and it leaves you with T equals 6.16, and you would use the level of significance table again. You go along 0.5 and along the DF and then circle where they cross over, and that gives you with the significance level of that test. So this one you would follow around as it is. As you'd follow around, you'd follow the tree, and it comes to a significant, not significant, independent t-test. Yep, so this one shows what t is equal to and gives the DF. So Pearson's rank order is a parametric test that is suitable when you have an interval ratio data and you're trying to identify the relationship between the two variables, because this could lead to, if one affects the other, positive, negative, or no correlation. It is a test of associations. This means you look at whether two or more variables could be related, and the test can either, you try and find the relationship between the two variables, and it's a simple correlation which you try to find out the relationship between the two variables. So you see, does one variable affect the other? And if you try to predict you could be able to predict the score with the independent variable if one increases because the other decreases. So there are 3 stages using the Pearson's product correlation: summing each of the set scores, squaring them, and summing them each of the scores, multiplying each pair of the scores by obtaining the cumulative sum of these products. So in the formula, n is the number of paired scores, e is the sum of, x is the scores of one variable, y is the scores of another variable, ex squared is the sum of raw scores for x squared, ey squared is the sum of raw scores for y squared, ex squared is the sum of all x squared scores, squared is the sum of all y scores. So to interpret the significance of your R value, select the level of significance. Remember that this is has to be lower than 0.05 to be significant, and find your degree of freedom for your test. For this test, use the formula DF is n minus 2 to compare your R value in the table of significance. So once you've got all your results, you go along 0.05, along the DF score, and as they lap over, that's your level of significance. So if it's less than 0.05, it's significant, and if it's not, it's not significant. An example of a non-parametric test is Spearman's rank order correlation. The rank order correlation is a test is also similar to the other one. However, it's a non-parametric equivalent, so it uses ordinal data, which is rank data, instead of the other type of data. This test should be used when you want to find the relationship between a set of data. The first step for your rank order is you have to rank your results from highest to lowest, with 1 being the highest. After this, you determine the difference between your data and place in the place, and this should be squared and summed. So the formula used for this is RS is 6ED squared, N brackets N2 minus 1. So N is the number of ranked pairs, D is the difference between each pair, and ED squared is the sum of ranks of the squared differences between the rank. So the interpretation of significance of your R value selects the level of significance which will be less than 0.05 and calculate the degree of freedom, the DF, for your test. For the Spearman's rank order correlation, you should calculate the formula n minus 2, compare them to the table of significance to see whether if it's less than 0.05 when they cross over, your results are significant.